We're here with FlexeGRAPH here at IDTechX show here in Berlin. So who are you?
Hi, I'm Shad Hallam, CEO and founder of FlexeGRAPH. We're here today as a startup here. We got a stand. Exciting times, a great day, lots of interesting stuff, and the ability to network with a lot of people from a cross-section of different technologies.
So why do you say cooling electrical vehicle batteries?
Yeah, so our technology is nano-enhanced fluids. So any closed-loop cooling system will benefit from our system. So graphene is in a solution or a suspension that we can use in any cooling system and replace
servers.
So a data center, so liquid-cooled data center is an example. We have here an example in a electric vehicle, so that the cooling of electric vehicle batteries or electric drivetrain components. And we also have use cases for heat exchange systems, so geothermal heat exchangers or industrial heat exchangers, and also high performance engines. Internal combustion engines can benefit from the product.
That's only high-end cars, it's not every car?
Any car can use it, but the benefits are potentially not there. Most cars today, the power is restricted, for emissions and other values. So the benefits of the system or the technology necessarily don't apply to a normal motor, but it can be used in a normal motor.
So you're saying you're 60% better than water?
60% better than water or any of the host fluids. So water glycol, water ethanol.
It's a big deal, no?
It is. It's the first breakthrough in this technology in around 90 years since glycol came into liquid cool systems.
Who did that? Who used that for what? 90 years ago?
Combustion engines.
So it's to cool them down, they were getting too hot?
Yeah.
For the first kind of like cars and trucks and...
Yeah, I believe so.
And then, or airplanes maybe?
Potentially, I would say that they were probably air-cooled to start with.
And so what is it going to enable all this?
If we look at it, and if we look at, say, an electric drivetrain, there's an issue with heat when it comes to charging, so it can allow faster charging. It could allow the increased density in batteries. I believe also if you look at cold temperatures, there's performance loss and capacity loss in extremely low temperature conditions. We'll be able to bring warmth to the system in a quicker way. And cycling time and longevity of battery life could also be enhanced without temperature peaks and the overheating of batteries.
Are you talking about charging the batteries faster?
Absolutely, and in the charging infrastructure is a use case as well. In the high power charging units, there's cooling in the actual cables.
That's what makes them expensive, or
that makes and very big and very heavy. So less coolant required with ours, so they wouldn't be as heavy. Plus, you could potentially increase the capacity further.
So those Teslas that have supercharged, right?
Yep.
They have issues, or the superchargers are more expensive because of all the cooling concerns?
Yeah, plus limitations, I think, in terms of the ability to charge as fast.
So is it graphene?
Graphene is the active component.
So it's right here. There's some graphene right here. This is your special
that's the fluid.
Mix?
Exactly, and this is water and graphene. So the graphene is making a dark grey in color.
So you have water too?
Yeah, it can be in water. Basically, whatever the base fluid is of any cooling system, our graphene enhancement will improve the thermal conductivity. So water glycol, water ethanol, and we're looking at other solutions going forward.
I'm just joking a little bit, but I think Intel should be very interested because their processors overheat a lot. No, I'm joking because my website is called ARM Devices, but maybe you could have a laptop that has a faster CPU that overclocks. And
yeah,
you can have a thinner design.
Exactly, and we're looking at different technologies involved, adhesives between electronic components. We also are looking at the next application is the development of our material that can be in direct contact with electric components. Graphene is electrically conductive, so we'd have to use another active component.
All right, so how soon, because there's a lot about graphene, it takes time to get into the market or something, but is it going to take time, or are you ready?
We've got the minimum viable product. What we need to do is get it into real systems and test them in real life systems. We're doing that with some geothermal in the coming weeks and months. With vehicles, it's a longer process. There's certification that's required to do that.
Nice. So that's awesome. Graphene is going to, and your way of doing it is going to cool
exactly.
Stuff better. How about,
cool stuff better.
Air
conditioning, if we look at it in terms of not evaporative, but heat pump systems, absolutely, there's use cases there. And as I said, geothermal cooling, heating, and if you turn it around, you could do it the reverse way and use it to having heat pumps that cool.
It's not for heating, it's for cooling.
Or heating.
You could be doing the reverse.
Yeah, it just moves heat more effectively inside the system. So